Okay, we're going to take a look at the second part of the review, where we're going to be taking a rational expression, which is just means we have fractions, and we're either multiplying or adding and subtracting, and so we're going to have to use our factoring techniques that we've been practicing. And let's take a look at this first problem, number 10, and we notice that the last term is being divided, so we're going to flip that fraction over and then multiply it instead of dividing. So we're going to just take it term by term, and we'll try to do this by colors. So we'll do the last fraction in red, we'll do the first one in blue, and we'll do the middle term in green, and see if we can keep it all straight here. So the numerator, this x minus 10, is already factored, and so we'll just not worry about that one so much. And we'll go ahead and do that one in blue. So we'll just leave the x minus 2 alone. And then we'll factor out the denominator. And we can either use crisscross on that, or we can just factor it out by guess and check. I think I'll do guess and check. So we're just going to basically need something that multiplies to get 10 and adds to get negative 7. Since our leading coefficient is 1, it makes this fairly easy. Well, 5 times 2 multiplies to get 10. It adds to get a positive 7, but a negative 5 and a negative 2 satisfy that. So, and we can see already that we're going to have some cancellation here. Alright, moving on to the green fraction. The denominator looks like it's already factored, but they both contain a 3, so we can divide a 3 out of that. So let's go ahead and divide a 3 out of that, and we'll just put that whole number 3 out in front like so, and we'll get an x plus 2. And then we'll just do the guess and check on the top. We need something that multiplies to get a negative 5 and adds to get a negative 4. So this one can be kind of tricky, but I think you'll see that it's just going to be 5 times 1, and we just need to make one of them negative. So we have x and 5 and x and 1. Since the middle term is a negative, we need to make the bigger number negative and the smaller number positive, so that takes care of that one. And then finally we're going to flip the red fraction upside down, and both terms are already factored, so the 6x that was on the bottom is now on top, and we have our x plus 1. So now all these are being multiplied together, so we can think of it as just one big fraction, right? First fraction multiplied by the second, and then by the third. So in black, I'll just denote that by making one great big fraction right there. Okay, so let's just cancel what we can and see what's left. And we'll use this yellow highlighter for that. So clearly we have an x minus 2 here, so those two terms cancel. Looks like we have an x minus 5 in the denominator and 1 in the numerator. And we have an x plus 1. And what else do we have? It looks like that's it, with the exception of this 6 and this 3 can both be divided by 3. So that's going to leave us with, this becomes just a 2x on top, and this green is now equal to 1, right? So putting it all together, what's left on the top is a 2x, and we'll write the final result in black. We have a 2x on top, and we have an x plus 2 on the bottom. Okay. Now the last thing we need to do is list what's the restrictions, or what's the domain on this. Remember, it's setting equal to 0 everything in the denominator. And so if we have a 0 on the bottom, it's undefined, so we're going to just identify those places. And so we're going to look right here, and we see that if we set this equal to 0, x would equal 5. So we're going to say that x cannot equal 5. And we also have x can equal positive 2. Even though we factor those out, we're still going to include those into the domain. And then finally this one, if we set that equal to 0, we would get a -2. Okay, looks like that's about it for that problem. So let's move on to number 11, which is not multiplying or dividing, it's adding and subtracting. So we're going to have to think about finding a common denominator. So we'll do the colors again on this one. Red seems just as good as any color. So this term is already factored out. So we're going to just leave it like it is. But we notice that we don't have a common denominator. But when we do the green fraction, the top is already factored, so I'll just leave that as minus. And then it looks like the bottom is a square minus a square. So we're going to factor that out. The square root of 16 is 4, so we have 4x. Square root of 1 is 1, so we have 4x minus 1. And we have 4x plus 1. So now we can start looking at the denominator so we can find a common denominator. And you'll notice that they both have 4x plus 1 in it, which is good. So all we have to do to this red fraction is multiply it by the missing element, which is 4x minus 1. So we'll do that with a 4x plus 1 and 4x plus 1 here. So this green fraction that I just added here, remember this is just the equivalent of 1, so we haven't changed the problem, we're just adding stuff to it, I guess, if you will. So let's look at what the result of the new red fraction is. Well, first of all, the denominator is common, so we can simply write it one time. And looking at the new numerator up here, we have 4x plus 1 times x, so we have to distribute that x to it. So this becomes 4x squared plus x, and then notice that we are subtracting in between, so minus, and I like to put a big parentheses there to remind me that I have to distribute the negative sign or the subtraction to both of these terms in the numerator. So if we do that, it looks like we have, roll this down just a little bit, looks like we have, I'll write it all together in black since we've sort of merged the two. We have a 4x squared, we have a plus x, and then distributing the negative sign we get a negative 2x. Distributing the negative sign of the plus 1 gives me a minus 1. So now let's just combine our like terms on the numerator, and we notice that we have a positive x and a negative 2x, so the result of that would be a negative x. So let me just erase that so I can save myself a little bit of time here. Negative x goes right there. And on the bottom we just write our denominator, which we already found. The common denominator is 4x minus 1 and 4x plus 1. Okay, well, I guess it's worth looking at the numerator to see if we can factor that. I don't believe we can. Is there anything that multiplies to get negative 4 and at the same time adds to get a negative 1? And I can't think of anything. 2 times 2 doesn't work. It either adds to get 4 or subtracts to get 0, and 4 times 1 added would be 5, subtracted would be 3, and that's not going to help us because we needed it to be a negative 1. So now, in fact, this problem is almost done. All we need to do is go back and write what the domain is. So the domain is the set of all real numbers with the exception of, we solve this, set that equal to 0. We have 4x minus 1 equals 0. So we add 1 to both sides, and we get 4x equals 1. Divide that out by 4, and of course that'll give us x equals to 4th. So the first thing that it can't equal is a positive 1/4, and clearly this one's going to end up giving us a negative 1/4. So that will be the domain for this second problem. Alright, well, I hope this helps you out, and good luck with finishing the review packet.